find it funny that the hourglass shape mimics the quartz crystal molecule shape as well, which is traditionally what our clocks is based on. The motion of the second hand is based on the frequency of the quartz crystal, and that's why a lot of clocks say quartz on the front. So the first concept of time was date, and that's pretty obvious. It's, the day of the month, the year, and that includes the time down to the seconds. And this is a traditional date stamp that bookkeepers use. And I took this screenshot on my phone. I looked up atomic time, and it turns out that there's a discrepancy, and we'll get into that in this video, why that is such a thing. So we're 37 seconds off. So let's define a second. The symbol is a lowercase s, also abbreviated as SEC. It's the base unit of time in the International System of Units. Although the historical definition of the unit was based on this division of the Earth's rotation cycle, the formal definition in the International System of Units, SI, is a much steadier timekeeper. The second is equal to the duration of 9,192,631,770 periods of the radiation corresponding to the transition between the hyperfine levels of the unperturbed ground state of the Cesium atom. This is the Cesium atom, so you can see its frequency bouncing around inside. And this is it on the periodic table. It is element number 55. Because the Earth's rotation varies and is also slowing very slightly, a leap second is added at irregular intervals to clock time to keep clocks in sync with Earth's rotation. A leap second is a 1 second adjustment that is occasionally applied to the Coordinated Universal Time to accommodate the difference between precise time and imprecise observed solar time, which varies due to irregularities. Coordinated Universal Time is the primary time standard by which the world regulates clocks and time. It is within about 1 second of mean solar time at 0 degrees longitude and is not adjusted for daylight saving time. It is effectively a successor to the Greenwich Mean Time. Greenwich Mean Time is the mean solar time at the Royal Observatory in Greenwich, London, counted from midnight. At different times in the past, it has been calculated in different ways, including being calculated from noon. As a consequence, it cannot be used to specify a particular time unless a context is given. And so here's the clock that the Greenwich Mean Time was based on, or is based on, and notice it's a magnetic clock. And I'm guessing that's why we switched from using that clock, because our magnetism is off thanks to CERN. International Atomic Time is a high-precision atomic coordinate time standard based on the notional passage of proper time on Earth's geoid. It is a continuous scale of time without leap seconds. It is the principal realization of terrestrial time with a fixed offset of epoch. It is also the basis for Coordinated Universal Time, which is used for civil timekeeping all over the Earth's surface. An epoch in chronology and periodization, an epoch or reference epoch is an instant in time chosen as the origin of a particular calendar era. The epoch serves as a reference point from which time is measured. Specifically, both Julian days and the Gregorian calendar are used. TAI in this form was synchronized with Universal Time at the beginning of 1958, and the two have drifted apart ever since, due to the changing motion of the Earth. The Julian day is the number of days that have passed since the initial epoch defined as noon Universal Time, Monday, the 1st of January, 4713 BC in the Julian calendar. That noon to noon day is defined as Julian Day Zero. Before the difference between the two scales reaches 0.9 seconds, a leap second is added to UTC. On average, Earth has been slowing down a bit over the past decades, so UTC is currently running 37 seconds behind TAI.
I said, Mike, you're not on the cutting edge of technology. You're a caveman. So everywhere we went up and down the place, he's saying, hey, he called me a caveman. He's calling me a cave. Because why? Because we think what we know, what we've accumulated in knowledge, we've accumulated over the last 75 to 100 years. Before that, the entire Earth was a blur. Nobody knew anything.
The 37 seconds result from the initial difference of 10 seconds at the start of 1972 plus 27 leap seconds in UTC since 1972. And I find it interesting that this is about the time of Generation X. And not to brag, because I'm a Gen Xer, but we have aged well, and I think that could have something to do with it. So in short, Sidereal Time is a timescale that is based on Earth's rotation relative to fixed stars. And let's take a look at the vernal equinox. That's the star it's referring to as far as the fixed star. This is your analemma. That's at the center. Now this is looking at sidereal time or star time. It's based on Earth's rotation relative to the stars instead of the sun. The sidereal day is almost 4 minutes shorter than our 24-hour day. When navigating by the stars, an observer will see the same constellation at the same place in the sky. Now this is showing you the sidereal day, its difference from the solar day measurement. Well, this is the second illustration. And hopefully that makes sense to you. So the mean solar time is the hour angle of the mean sun plus 12 hours. This 12-hour offset comes from the decision to make each day start at midnight for civil purposes, whereas the hour angle, or the mean sun, is measured from the local meridian. As of 2009, this is realized with the UT timescale constructed mathematically from very long baseline interferometry observations of the diurnal motions of radio sources located in other galaxies and other observations. The duration of daylight varies during the year, but the length of a mean solar day is nearly constant, unlike that of an apparent solar day. An apparent solar day can be 20 seconds shorter or 30 seconds longer than a mean solar day. Long or short days occur in succession, so the difference builds up until mean time is ahead of apparent time by about 14 minutes near February 6th. Sorry, I'm just reading everything I found. I'm not making any of this up. Consider a first fictitious sun traveling along the ecliptic. And that's the ecliptic there on the celestial sphere. With a constant speed and coinciding with the true sun at the perigee, which is perihelion, actually. An apogee when the Earth is in perihelion and aphelion respectively. Then consider a second fictitious sun traveling along the celestial. And that's your celestial equator at a constant speed and coinciding with the first fictitious sun at the equinoxes. This second fictitious sun is the mean sun. And there's even an illustration of this. This is all from Wikipedia. The length of the mean solar day is slowly increasing due to the tidal acceleration of the moon by Earth and the corresponding slowing of the Earth's rotation by the moon. This is all just way too mind-popping. I hope that this is making sense to you guys, because it's truly not making a whole lot of sense to me by the end of it. And this is definitely going to require a lot more deep diving and a lot of comments from you guys. I want to know what you all know about time. And I promised a viewer that I would get into the Anahulu, which kind of coincides with all of the Hebrew stuff. So that is also one thing I really noticed about this video, is it didn't include the moon hardly at all. So we'll see how it goes.
And that leaves you with some very fucking interesting people. Get yourself a Gen X friend, but they'll probably just tell you to fuck off.
No, but seriously, we have a lunar eclipse coming up at the full moon in about a week and a half, 2 weeks from now. So stay tuned for that. I'm going to do a video for that for sure. And what else is coming up? Oh, the lunar concepts of time, because this video, like I said, covered mostly solar. So let's get into this, you guys. Thank you for deep diving with me, and I'll talk to you soon. Much love. Peace.
There is that light that you